Imagine that you're in a spaceship and you are flying that spaceship through space, and you've got these clouds of purple space dust in front of you, and that's what we've called element alpha. You are steering your spaceship to the left and to the right as you go through those densest parts. And what you're doing is you're leaving a trail behind you, you're tracing a path through space. And it's that path which is really invaluable to our scientists.
This project started a year and a half ago. We were looking at the copy number and the expression changes in 2,000 breast cancer tumors. We were looking at the data and we were seeing that the algorithms that we use for detecting these copy number alterations, they are very accurate, but only to 90 or 95% of the cases. We were seeing that in many cases it was clear that the human eye could detect the right answer, that means detecting the real change, but the algorithm wasn't able to.
The scientific element is actually identify anomalies in the genetic code of cancer patients. In order to do that, we're basically looking at very big, long chromosome data and looking for where that deviates from the norm. You basically fly your spaceship down a route which represents the chromosome and the element alpha path, and then as you kind of fly to the left or right trying to collect more element alpha, that maps the genetic code that feeds back to our scientists, which they can then see the anomalies that we're looking for. It's meant to be a really immersive, fun experience, but obviously it all travels back to the scientific work that we're trying to understand.
There are some things that the human eye and the human brain can do much, much better than a computer. So things like spot the difference or pattern recognition. If you think about reCAPTCHA, so when you are buying something online and you need to prove that you're a real person, and they give you those kind of wiggly, fuzzy letters and numbers that you need to decode, that can fool computer programs. They can't do that kind of recognition. But as humans, we can see relatively easily that something is maybe a sort of fuzzy H or a slightly curvy 1.
That's when the idea of crowdsourcing and trying to convert this into a game where people can help us looking at all this data will come into play.
So 2 years ago, we developed our first product, Cell Slider. That's done phenomenally well. In 18 months, we've had over 200,000 people from all around the world who have done more than 2 million classifications. And what's really exciting is that in just 3 months, they had analysed data which took our researchers 18 months to do. So they were 6 times faster. And that was when we thought, what if we could do something much bigger, something really ambitious that had never been done before? And that's when we came up with the idea of Play to Cure, so that people could be playing a mobile phone game and at the same time analysing cancer data. And that was the beginning of the journey towards what is now Genes in Space.
The first thing we did with that was have a hackathon, which was great. Had dozens of people to bounce off some of the ideas and look at what we could actually do in a mobile phone app that would help to cure cancer.
I think the thing that surprised me the most was just the production values associated with it. I mean, you have 3D spaceship models, they're quite shiny, they have sort of lots of little neat graphical effects, which is not something I'm used to seeing in just kind of like mobile games in general, and certainly not something I would expect from a charitable project where you sort of feel like it would be too frivolous, but actually it brings a lot to the game and makes it more kind of like appealing, more catchy. Everybody has effectively a computer or even a supercomputer in their pocket or in their bag. In the past, it's been more the case that games have been used to communicate ideas and spread awareness. This game is doing something fairly new, and it will be interesting to see how other games can make use of remote data crunching in this way.
If everybody who had a smartphone downloaded this game and played it, the impact could be absolutely mind-blowing in terms of the amount of analysis that people all around the world could do. And we want everybody to be able to have that sort of involvement in beating cancer.